Theorem 9, the 10-chord theorem. This is what we're going to be working on in this tutorial. So it's quite a famous theorem. So if you're slightly a bit disorientated in terms of how this theorem works and all that, then this tutorial is definitely gonna help. Hi guys, Lever here from Bright Young Brains. So we already stated that theorem 9 is quite common. The first thing you want to keep in mind though is this theorem comes in two parts, or it always comes with a pair. What I mean is this angle there will be equal to that angle there. This one here will be equal to that one up there. Now the key thing with the 10-chord theorem is you just want to keep in mind that this theorem will only hold if you have this entire triangle inside this circle. So what I mean is, if we had a circle and a chord there, another chord there, this is a portion of a tangent, and then that's another portion of a tangent. So in a situation like this one, we don't have the 10-chord theorem there, because even though we have a portion of a tangent, a portion of a tangent, and a chord there and a chord there, we don't have a full triangle inside the circle there. So the theorem does not hold for anything, you see. So it may seem weird that I'm mentioning this, but just keep that in mind. So for this theorem to hold, you need two chords, and then these two chords obviously need to be joined by a line in some way, and then you need a tangent where your triangle is touching. So in words, your 10-chord theorem the theorem states the angle between the tangent to a circle and chord drawn from the point of tangency is equal to the angle in the opposite circle segment. So we stated that this angle here will need to be equal to this angle here, which is in the opposite circle segment, and then this angle here will need to be equal to that angle there, because that's the one that is in the opposite circle segment relative to this particular angle. So that's the 10-chord theorem in words. Now with this 10-chord theorem, we need to also know how to prove this 10-chord theorem. So when you need to prove your 10-chord theorem, you will generally be given a sketch that is plain, like the one that we have here. Proving this theorem is not as straightforward as the others. However, you do want to have a good idea of 3 laws or 3 theorems. Those 3 theorems the theorem that states that an angle subtended by the diameter of a circle is equal to 90 degrees. A line that is the radius of a circle will always meet a tangent at an angle of 90 degrees. And then the third one is that angles subtended by the same arc are equal. We're going to use these 3 theorems to prove theorem 9. So you see, theorem 9 is quite chunky. So if you're not familiar with these, or you're not comfortable with these, then it's best that you go through the previous tutorials in this Euclidean geometry playlist before jumping into this. So with this theorem though, we need to keep in mind that proving this, we need to construct 2 lines. Now that construction will always have the diameter of your circle, and then your other line will either go to B or go to A, depending on if they're asking you to prove that these 2 are equal, or they're asking you to prove that these 2 are equal. Now what I mean by that is, firstly, if they were asking you to prove that BCD is equal to BAC, if that was the question, then your construction would have the diameter of your circle, and then you always make sure that your other dotted line goes to A. If they were asking you to prove that ACE is equal to ABC, then your other dotted line would be going to where B is. So that's a big issue. Keep that in mind whenever you're proving this theorem, because firstly, in terms of your construction, the diameter will always be there, But then depending on where your second dotted line goes to, that is all dependent on whether they're asking you to prove that these two are the ones that are equal, or whether they're asking you to prove that these two are the ones that are equal. Both of them, as in both pairs are equal, yes. However, in terms of you proving this law, you would only be using one pair. In our case, if we are going to have our construction in this manner, our question would have easily asked us to prove that ABC is equal to ACE. So in a situation like this one, we know that we would construct our diameter, and then we need to construct our dotted line going to angle B there. So putting that in words, we would just need to state that we need to construct FOC and then mention that that's the diameter, and then we also need to construct FB. So having to have made these two constructions, we have somewhat put ourselves in a situation or in a position where we can prove theorem 9 using these three other theorems. To do that, one thing you want to keep in mind is take things bit by bit. You make your construction and then try and use one law at a time, because we're going to use this law first, and then we're going to move on to this one, and then we're going to move on to that one, somewhat in that order. Try and use this first, and then this law, and then this law afterwards. So to start off, thinking of what this theorem states. In our case, we know that with the construction, we always eventually need to label our sketch properly. So in our case, C here, we can label it as C1 and C2. B here, we can label it as B1 and B2. So you see here, I have B1 and C1 highlighted, obviously because we are trying to prove that those two are equal to each other. So remember, you cannot use a theorem to prove a theorem. Yeah, so what I mean is, we cannot bluntly just state that C1 is equal to B1 because of the 10-chord theorem. No, that's not how it works. We're trying to prove the 10-chord theorem. So firstly, after labeling your sketch, the one thing is you want to go to this law, and then you want to remember that where C1 and C2 is, we know that the angle there is equal to 90 degrees. So just remember this law and state that C1 plus C2 there is equal to 90, because of your tangent will always need to be perpendicular to the radius of a circle. So writing that down, this is all that we have. The next theorem we need to use is this one. Now using this one, we need to refer to where B1 and B2 is. And if you check where B1 and B2 is, firstly, this angle, you're also going to state that this portion, B1 and B2 added together, is equal to 90. And your reason for that is that this angle is subtended by the diameter of your circle because of your construction. So here, there we go. B1 plus B2 is equal to 90 because this is an angle that is subtended by the diameter of a circle. So we've used this law, you have made use of this law, now to make use of this one. And we said try and do it in that order so that you have some form of structure that you can always refer back to whenever you have a question like this one. So now that we have used these two theorems, the third one, what you now need to do is, firstly, if you look closely, B2 and C2, these are now somewhat angles that are being subtended by the same arc there. You see, B2 is an angle that is going to F, going to A. C2, it is going to F, going to A. So those two are angles that are subtended by the same arc. So you're just going to state that B2 is equal to C2 because they are angles subtended by the same arc there. And then all that is thanks to your construction. That's why you want to remember that when you prove theorems, knowing what to construct is a big game changer. So let's just write that down quickly. So there we go. Angles subtended by the same arc. Now, having to have used all our three theorems now, things have somewhat fallen into place. What we now know is, here if you check, we stated this and then we stated this statement as well. And now our last statement, we have shown that B2 is equal to C2. So if you look at these two here, B2 is equal to C2 there. So before we write out anything funny, clearly if these two are equal to each other, and this adds up to 90 and this also adds up to 90, technically it means that these two will be equal to each other. So let's put that in writing. There we go. So there's a lot of therefores here, but that's it. Our three theorems here have helped us write out these three statements. And after writing these three statements, we see that if you isolate C1 here and you isolate B1 there, this is what we're ending up with. C1 on its own, it is equal to 90 minus C2 if you take the C2 over. Here, B1, it is equal to 90 minus B2 if you take the B2 over. And then we have stated that B2 is equal to C2. So these two statements here, hypothetically speaking, they are somewhat identical. So here, after writing this down, we can conclude that C1 is equal to B1. And then in our case, C1 and B1 refer to angle ABC and angle ACE there. So usually whenever you're proving something, try to end up with a statement that is directly linked to what your question was saying. If you had left it at this, you will still get all your marks, unless you have a weird examiner. But yeah, so that's all you need to know for theorem 9. It is simple. If you can remember these three theorems, and again, if you have not gone through these or you're not comfortable with these, then I suggest you go through the playlist. It will help you with this proof here. So as always, if you're working on something and it's a bit difficult and just super stuck, just send a DM on IG at LE_LEVY. No, just send a DM on IG at LE_EVY. So what I basically do is, if you send me a question, if it's super difficult, I quickly make a video of it on a piece of paper, and then I upload it onto my IG math page, which is at 0aesthetics, just mathematics. So there are quite a bunch of posts there on actual exam style questions that we have gone through, so you can have a look at that.